Hi everyone, welcome to my YouTube channel. So I'm Mr. Darren. So today I'm going to show you some lab simulation that I have done, okay, with you all. So I believe that most of the Form 5 students that have studied about the redox equilibrium. So in this chapter, at the first subtopic 1.1, oxidation and reduction, you're going to learn on the different aspects to determine whether the chemical equations is either in the reductions or oxidations. From four aspects, right? First is the transfer of oxygens, and then transfer of hydrogens, and also flow of electrons, and also the changes in oxidation number. So in one of the parts where we learn about the flow of electrons, there's one experiment that you have to know is about the electron transfer at a distance. So there is a apparatus set up on the U tube. Okay, the U-shaped tube is not the YouTube that you're watching right now, but it's a U-shaped tube. Okay, which connected with both carbon electrodes connected to a galvanometer. So sometime in the exam they won't connect it to a galvanometer, whereas they will connect to a bulb. Okay, electric bulb, so light bulb. So galvanometer actually is used to detect any current flow. Okay, it's used to detect. So you will learn more about galvanometer in your physics. Okay, or either they use a light bulb to see whether there's current flow or not. Okay, so in your textbook there is stated of several reducing agents and also oxidizing agent, as what you can see from the left hand side. Okay, on the chemical shelf. Okay, so they have iron 2 sulfates, potassium iodide solution, potassium bromide, acidified potassium manganate 7 solutions, and also iron 3 chloride, bromine water, chlorine water, and also acidified potassium dichromate 6 solutions. Okay, so and you need to know the initial color, right? So usually in the exam they will ask you about the observations. So what is the color changes? So in chemistry, observation is very important, where you need to write the initial color and the final color of the solution if there is color changes. Okay, and then usually in the exam they will also ask you to determine what is write the half equations. So the oxidation half equations, the reduction half equations. Okay, you also need to ask to determine terminal. X is terminal or positive terminal or negative terminal, and you also need to identify indicate the electron flow, either if from X to Y or from Y to X. So this one is very depends on your understanding on the reducing agent and also oxidizing agents. Okay, so today let me show you some example, okay, using these simulations which I developed my own. So for example, you have let's try with reducing agent. So what if we put both arm with reducing agent? Anything happen? So you can see, so the initial color of the iron 2 sulfate is green color, okay, or pale green. So why there is pale green color is because the presence of the iron 2 ion, okay, the iron 2 ion Fe2 plus. So and then we put potassium bromide. So potassium bromide is colorless, so you can see there's no electron transfer. Okay, there's no electron transfer, no reaction. Why? Because both of these chemical is the both are the reducing agent. So there is no electron transfer between these two agents. Okay, these two chemical solutions. So now let me reset the experiment. So same thing occurs if we put both arm with the oxidizing agents. Okay, let's put the acidified potassium manganate 7 solutions and also iron 3 chloride. But you can drag and put. Yeah, you can see there's no electron transfer because both are oxidizing agents. So let me reset the experiment. So now let us try the correct one. So we put one reducing agents, so iron 2 sulfate, and one oxidizing agent. So what we want to choose? Maybe we choose iron 3 chloride. Okay. So you can see the galvanometer deflect, and the initial color of the iron 2 sulfate is green color. After the reaction it changed to brown color. Why? Because you can see the half equations. Because the iron 2 ion is being oxidized to become iron 3 ions, where we all know iron 3 ion is brown color. Whereas the iron 3 chloride is being reduced, the iron 3 is being reduced to iron 2. So the brown color will turn back to pale green. So reaction occur. Okay, so we can show the overall ionic equation. So this is the overall ionic equations. Because usually how we going to write the ionic equations? You need first step, you need to make sure that the number of electrons for the both half equations are the same. Okay, like this one both have one electrons, so you can cancel each off and then you just write down, so you can get your overall ionic equations. Okay, so another question usually they will ask you to indicate the direction of current or indicate the direction of electron flow. Okay, we can see that the electron flow is from arm X to arm Y. Why? Because oxidation, OIL. Okay, oxidation is loss of electrons. So the electron will lost from the arm X and flow to arm Y. So usually the electrons will flow from the reducing agents to the oxidizing agents. Okay, and then you can show the terminal. So where is the terminal where the electrons come out is the negative terminal. Okay, the electron will come out from the negative terminal. So in this situation, in this case, the negative terminal will be the arm X. Okay, because electrons come out from there, as the iron 2 sulfate is the reducing agent. So you can write the observation also. So the pale green solution turns brown, and the brown solutions turn pale green. So usually this is the questions that usually being asked in your exam. Ask you to identify the agents, ask you to indicate the current flow, the electrons flow, and also indicate the terminal, and then write the observations. So therefore, it's very important for you all to understand, okay, to memorize the initial color and the final color. Okay, so now we try to reset the experiment. Okay, now we try to use a acidified potassium manganate 7 solution, and we put at the arm X. It's purple color. Okay, so the initial color is purple color, and then we put another side with potassium bromide. Let's see what happened. So you can see that galvanometer deflect and the observations. So initially the potassium manganate 7 solution is purple color, right? So after the reactions, it turns to colorless. So you can see the observations. So the purple solution turns colorless, whereas the initial solution for the potassium bromide is colorless. At the end of the reactions, it turns to brown color, because due to the presence of bromine molecule. Okay, bromine molecule, Br2. Okay, so this is the oxidation half equations and the reduction half equations. Okay, so and you can see the overall ionic equations is like this. Okay, so you need to balance, because here got 2 electrons, here got 5 electrons, so you need to multiply both until they have same. So usually we multiply the first equation with 5 and then the second equation with 2, so they can cancel each other to write the overall ionic equations over here. And then the electron flow. So electron flow from the reducing agents to the oxidizing agents, and also the terminal. So the negative terminal always where the electrons come out from. Okay, so it's over here is the negative terminal. So over here we have all type of the oxidizing agent and reducing agent which are being stated in your textbook, and also the observation you can see is basically same as what being indicated in your textbook. So you can see the orange solutions turn green, and also the color solution turn brown. So you can try all this stuff and the link. So later on I will put the link at the description, and all of you can go and explore it if you're on computer. Preferably use computer, don't use phone, because it's hard for you to drag. Okay, so because this website is usually is being developed based on the computer versions. Okay, so that's all for this video. We'll see you all on the next video. Bye.